Namaskar. Welcome to Exercise Explained. In this video, I would be solving question number 12 and question number 13 of exercise 8A, Current Electricity, ICSE 10th Physics. The previous questions have been done in the previous video, the link for which will be provided in the description. If you like the video, do share it with your friends and consider subscribing to the channel. Starting with the 12th question. What length of copper wire? That means we are supposed to find the length of resistivity. So resistivity, that is rho, is given as 1.7 into 10 to the power of minus 8 ohm meter. And radius, so radius is given as 1 millimeter. Now when we convert millimeter to meter, we multiply by 10 to the power of minus 3. So we can write 1 millimeter as 10 to the power of minus 3 meters required, so that its resistance is 1 ohm. So resistance is supposed to be 1 ohms. So we will be writing our formula for resistance, that happens to be R is equal to rho into L divided by A. So from this we can write left hand side as right hand side and right hand side as left hand side. So we get rho L by A is equal to R. So from this, L can be written as R into A, that is A into R we can write, divided by rho. So that would give us our length. Now since we have the radius, we can find the area by using the formula pi r square. So L would be equal to, area would be pi into r square is going to be 10 to the power of minus 3 the whole square into r is 1, the entire thing divided by rho is given as 1.7 into 10 to the power of minus 8. So now we would be expanding the things over here. So we can write pi as 3.14 into 10 to the power of minus 3 square would be 10 to the power of minus 6 divided by 1.7 into 10 to the power of minus 8. Now 10 to the power of minus 8 goes to the numerator, and 3.14 divided by 1.7 gives us 1.84. So we get 1.84 into 10 to the power of minus 6 into 10 to the power of plus 8. So minus 6 plus 8 gives us 10 to the power of 2. So we get this as 1.84 into 10 to the power of plus 2. So we get the final answer as 184 meters. So the length required is 184 meters. This was a straightforward question with only a bit difficult calculation here. So getting into the next question, that is the 13th question. The filament of a bulb takes 100 milliampere when potential difference current 100 milliampere. So I can write I1 is equal to 100 milliampere. Now we have to convert it to amperes. So in order to convert milliampere to ampere, we have to multiply by 10 to the power of minus 3. So 100 can be written as 10 to the power of 2 into 10 to the power of minus 3 ampere. So we can write it as 2 minus 3 is minus 1. So 10 to the power of minus 1 ampere, or we can write it as 0.1, because 10 to the power of minus 1 is 1 by 10 and 1 by 10 is 0.1. So 0.1 ampere we can write I1. When potential difference across it is 0.2 volts. So V1 is given as 0.2 volts. Now coming to I2, I2 is given as when the potential difference is 1 volt, the current becomes 400 milliamps. So it is given as 400 milliampere. So again, when we convert 400 can be written as 4 into 10 to the power of 2, because 4 into 100, so 4 into 10 to the power of 2 into 10 to the power of minus 3 amperes, because when we are converting milliampere to ampere, again we multiply by 10 to the power of minus 3. So we get this as 4 into 10 to the power of minus 1 ampere, or we can write it as 0.4 ampere. So that is the value of our I2, and the second potential difference is given as 1 volts. Calculate the resistance of the filament in each case and account for the difference. So we would be finding R1, so we would be using Ohm's law. So Ohm's law would give us V is equal to I into R, or we get R is equal to V divided by I. So R gives us V by I. So taking case 1, we will be getting R1 is equal to V1 divided by I1. So R1 will be equal to V1 is 0.2 divided by I1 is 0.1. So we multiply numerator and denominator by 10 to remove the decimal. So we get R1 is equal to 2 divided by 1, or we can write straight away R1 is equal to 2 ohms. So for the first resistance is 2 ohms. Now we will be getting into case 2. So for case 2, R2 will be equal to V2 divided by I2. So R2 will be equal to, our V2 is 1 divided by I2 is 0.4. So I would multiply here by 100 actually, instead of multiplying by 10. I would tell you the reason in a while. So to remove the decimal basically, but I'm multiplying with 100. So multiplying and dividing by 100. So we get R2 is equal to 1 into 100 is 100 divided by, this can be written as 4 into 10. It is 40. 0.4 into 100 is 40, but I have written it as 4 into 10. Now we can cancel this here. So this was the reason I have multiplied by 100. So 4 into 25 times is 100. So we get R2 is equal to 25 by 10. So 25 by 10 is 2.5 ohms. So we can see R2 is greater than R1. So the conclusion for this is resistance increases with temperature. So we can write resistance increases with temperature. So that would be the conclusion here. So this completes this particular exercise, that is exercise 8A. Hope you guys have liked the videos. Do share it with your friends and consider subscribing to the channel. The next video would be on exercise 8B. which would be uploaded in the channel soon. So see you guys in the next video. Till then, dhanyavad.